Here we go, 15. Yeah, number 15, we're going to check. We're going to talk quickly about why every single answer is true or false. Because as you prepare for a test, it's not enough to simply solve the problem. You're trying to make sure you understand the concept. So, please raise your hand if you can explain why A is true or false. Raise your hand if you can explain why A is true or false. Let's go, Hallie.
It's false because at -1, the y-coordinate is positive, which means that the f graph would be increasing.
It's a pleasure there for just 1 second. You said that exceptionally well. 3 points for that. No, really, listen to what she said. It was perfect. She said, at x equal -1, on the graph of f prime, the y-coordinate is positive. And then I kind of jumped in because I was so excited. I assume you're coming here to say, oh look, if the f prime graph has a y-coordinate that is positive, that means at that point, the graph of f would have to be increasing, not decreasing. How many note force you said it? Point. So this is definitely a false statement. And what I'm most excited about, of course, is that your reasoning was perfect. It's good work. Anybody else?
I guess I'll also look at it because it is a prime, so it's like when it crosses 0, it's when it changes to decreasing, right?
That is correct. Don't swear though, please. Point for Justin. Okay, part B. Okay, does anyone have any question about A? Any question about A? Okay, if you understand A, you should be good. If you're not, it's okay, but you should be good to know why B is the correct statement. But if you need me to discuss why B is correct, just wait. It's the same logic as A. It says F is increasing. I look over here. F is only increasing on an interval where every y-coordinate of f prime is positive. So they say the interval is from -2 to 0. And sure enough, on that interval, every y-coordinate has a positive value. Every y-coordinate of f prime is positive. Therefore, if every y-coordinate of f prime is positive, then every corresponding y-coordinate of f will be going up. Question?
So would that like make like a concave pound? On like that graph, or like just like rounding up?
I don't, for the AP test, they hardly ever ask me to draw anything, so I just stopped worrying about drawing it.
I'm not like drawing, just drawing a picture in your head.
I don't know. All I know is this. F goes up. That's all I know. These are all positive, F goes up. That's all I know. Anybody else? Okay. Part C is the same reasoning. You need help with part C. Shaking your head is very helpful. Point if you shook your head. Thank you. D, F has a local minimum at x equals 0. So clearing this off for a minute. F has a local minimum at x equals 0. One way to test if you're understanding the concept is this. This statement is false because we've already found the true statement. If you understand how to make this statement true, it shows really good understanding. Like, how would this statement need to be changed to become a true statement? Go, Tori?
You changed it to x equals 1.
So Tori says, let's look over here at x equal 1. 2 points for Tori. You're making a small mistake. Let me just point it out. This is the graph of f prime. And right here, f prime, everyone note this, is changing from decrease to increase. That means f prime has a relative min. So that is a true statement that right here on f prime, when f prime changes decrease to increase, f prime definitely has a relative min, absolutely. This one's talking about F, so you don't want to cross that up. Ashley.
Is it F has a local maximum?
Perfect. If you put local max, we look up here at x equals 0, and we notice F prime is changing from positive y values to negative y values. So F prime is doing this, which means the unseen graph of F will do this. If F changes increase to decrease, F has a relative max.
On that little corner, on the F graph, would that be an inflection point?
Listen close to Elena, 2 points. When F prime changes from decrease to increase, the graph of F certainly has an inflection point. A change on F from concave down to concave up. Perfect. Okay, if you listen to me talk, I hope you keep hearing. I try super hard to never speak of anything without specifically stating F or F prime or F double prime. You need to practice the same. Like, it forces your brain to hurt a little bit, it really does. It's like you have to talk in a robotic, that keeps stopping. But if you'll think, okay, what am I talking about? This is F prime. F prime is changing from positive y coordinates to negative y coordinates. So F itself will have a relative max. Any questions on D? Okay, part E we did a little bit last time, I think, but let's talk about it again. I would have a card. Card would say this. On one side it would say F is differentiable, question mark. F is differentiable, question mark. And on the other side, it would say 1. I can find the tangent slope, comma, derivative, comma, rate of change,
There you go.
the inst rock of F. That's what it means for F to be differentiable. If F is differentiable, I can find tangent slope, comma, derivative, comma, instantaneous rate of change of F. That's one meaning of the word differentiable. Okay? Let people catch up. Number 2, I can find every y coordinate of F prime. Because the y coordinates of F prime are the tangent slopes of F. So if F is differentiable, I can find every y coordinate of F prime. This is why I say you must understand first, then when you create the flashcard makes sense to you. Then it becomes much easier to remember.
So everyone could have F prime.
Of F prime.
Because then you can have a slope.
Of F.
That is.
Yes. Because F is differentiable. Yeah, see Josh getting warmed up.
Let's go.
Let's go. All right. Say that right? It's like being in Brazil all over again. Say that right. Like, no, really, we understand that. Look. Terrible. Okay. So F is differentiable. That's one side of the card. Other side of the card says, therefore, I can find tangent slope, derivative, instantaneous rate of change of F. Number 2, so I can find every y coordinate of F prime. Number 3 is F is not differentiable if F has, there we go, discontinuity, corner, or vertical tangent. So F is not differentiable. So we did this before, just making flashcards now. F is not differentiable if F has a discontinuity, vertical tangent, or corner. F, not mix up.
Discontinuity plus.
So F is not differentiable if F has a discontinuity, corner, or vertical tangent. That's what will make F not differentiable. Question. We're almost done. So, I look at the board right here. They want to know, is f not differentiable at x equal -1? I am reminded of Hallie's comment. Another point for Hallie. That'd be 2 technically, since I said your name twice. Keep nodding there. Let's see, x equal -1. So right here, this is the graph of f prime. Just a reminder on the test. You are not going to see a single question that is fill in the blank. You know, that says, what is the meaning of differentiable? Okay, that is not the world we live in this class. The world we live in is, here's the concept. Can you apply it to this weird thing they're asking over here? That's what you got to do. Okay, look. This is the point -1. The y-coordinate is not listed, although if you made a reasonable assumption maybe that scale is about the same, that y-coordinate would be about 2. This y-coordinate of 2 on the graph of f prime, hands up, what is that telling you about the graph of f? Hands, come on. This y-coordinate here of 2, Hallie already told us, there's 3, that it means f is increasing, but more specifically, what is this y-coordinate of 2 on the graph of f prime telling us, Julia?
At the point x equals -1 on the f graph, and the slope is 2.
Can't say it better. On the graph of f, at x equal -1, the slope is going to be 2. If you can find the slope of f at x equal -1, f is differentiable at that point.
If that were to say f prime, would then that be correct?
That is correct. F prime is not differentiable here due to the corner on f prime. Question? Sydney, please.
What's the difference between differentiable and then twice differentiable? Like there's like a couple questions that have like twice differentiable.
Gotcha. So, are you feeling, we got 40 seconds, listen close. Are you feeling good about what differentiable means? Okay, so differentiable means start with f, I can find the derivative to get f prime. Twice differentiable means you can just do it again. So you can take whatever values you found for f prime, make a graph, find all those tangent slopes to create f double prime. That's all. Good work today, good work.